Hello, we're here to present on the topic driverless technology, a solution to roadway fatalities. Our team consists of Alimran, Nicholas, Ryan, Deb, and Aaron.
Every year, approximately 1.2 million people lose their lives in road accidents. But shocking in that number is according to WHO, 94% of these crashes are by human errors, which means mistakes that could have been avoided. Now, our goal for this presentation is how autonomous vehicles could be the key in solving this problem. We'll discuss the benefits, the challenges, and also how this connects to the 50 grand challenges of our world. Let's talk a bit about numbers. Now, according to WHO again, the data is alarming. Road traffic injuries are a leading cause of death for children and young adults aged 5 to 29. These aren't statistics. Each number represents a real life lost every single day. It's clear that we need smarter solutions. Now, let's move on to the background. According to WHO, just a 1% increase in speed raises the risk factor of a fatal crash by 4%. Now, if you add in factors like drunk driving, texting behind wheels, and not wearing proper equipment, it's a recipe for disaster. It basically tells us that human behavior remains the biggest risk factor in road accidents.
In this presentation, we'll explore how driverless technology can dramatically reduce fatalities and why accelerating its development could save thousands of lives every single day. Worldwide, over 1.2 million people die due to car crashes every year. In the USA alone, there were 5.3 million car crashes with 2.2 million injuries and 32,000 deaths in 2011 alone. These numbers have likely increased since then due to an increase in population and thus an increase in car ownership. Car crashes result in billions of dollars of losses every year. Currently, 94% of car crashes are caused by human error. With the elimination of human error, autonomous vehicles will drastically reduce the number of car crashes that occur.
Now we move to the main topic, autonomous vehicles. An autonomous vehicle is a vehicle that drives itself without any human input, and it uses advanced techniques. Now we can see the level of autonomy. We have the level 0 to level 5. Level 0. Car driver does everything. Level 1, car assists with one task, cruise control. Level 2, car handles steering and speed. Driver stays alert. Level 3, car drives in some situations. Driver takes over if needed. Level 4, car drives itself in most cases where human help. Level 5, fully self-driving, no human help. No driver needed. Today, most commercial systems operate level 2, offering support like adaptive cruise control and lane keeping. Levels 4 and 5 are where the real transformation begins, allowing cars to drive without any human input, even in complex environments. How does autonomous vehicle work? Autonomous vehicles use combination of sensors to detect surroundings, LIDAR radar, cameras, GPS, artificial intelligence, AI, to interpret data and make driving decisions, control systems to steer, accelerate, and brake automatically, connectivity to communicate with other vehicles and infrastructures. Why fully autonomy matters. Fully autonomy has the potential to transform road safety. Unlike humans, autonomous systems don't get tired, distracted, or impaired. They follow traffic laws precisely and react faster than any person could. By removing the human error factor responsible for most of the crashes nowadays, we could see a dramatic drop in accidents and lives lost.
Balancing innovation with safety is a core challenge in the development of autonomous vehicles. While there's a need to move quickly to save lives, we must also ensure that technology is thoroughly tested and proven. Controlled trials, gradual feature rollouts, and continuous learning from real-world data can help us innovate responsibly. The ultimate goal is to save lives, not rush to market at the cost of safety. The chart shows that while autonomous vehicles get into more accidents than human driver-driven ones, they result in fewer injuries. that suggests autonomous vehicles may be involved in more low impact or cautious collisions. It's a sign that the technology is still evolving, but also that it could already be reducing the severity of crashes. Transitioning to a driverless future isn't just a technological challenge, it's also about winning public trust. According to a recent AAA survey, 71% of Americans are afraid to ride in fully autonomous vehicles, though many are more comfortable with limited use applications like airport shuttles. People are hesitant for several reasons: fear of losing control, doubts of any safety, not understanding how the technology works, and concerns about hacking. In fact, 43% of people still don't feel safe in an autonomous vehicle, whether as a driver or passenger. So even though autonomous vehicles have the potential to reduce accidents, public skepticism is a major hurdle we'll need to overcome. There's four things we have to consider: the trolley problem slash crash dilemmas. One of the most debated ethical questions in autonomous vehicle development is how the vehicle should behave in a no-win scenario. Should it prioritize the safety of passengers, pedestrians, or the greater number of lives? The second thing is bias in AI decision making. Could autonomous vehicles inherit biases in data? Example, recognizing pedestrians of different races or body types unequally. How can developers ensure fair and equitable decisions? The third thing is liability and accountability. Who is responsible when something goes wrong? The manufacturer, the software developer, or the owner? And how do we define negligence when the driver is a machine? And the last thing is data privacy and surveillance. Autonomous vehicles collect massive amounts of location and behavioral data. How should this data be stored, used, and protected?
In conclusion, driverless technology represents more than just innovation. It is a chance for us to save lives. Human error continues to be the leading cause of crashes, and we believe that autonomous vehicle has the potential to significantly reduce both accidents and the severity of injury. Of course, we know that challenges like public trust, regulations, and ethical concern still needs to be addressed. But we believe with responsible development of this technology, a safer and smarter transportation future is within reach. These are our list of references. Thank you.